Lesson 20 is other methods of factoring quadratics. So we've learned about like factoring GCF and factor by grouping in lesson 19. So if you haven't already watched lesson 19, make sure you go back and watch that first because today is definitely going to build off of it. So 20.1 is called the decomposition method. So example 1, factor 2x squared minus 9x minus 5. So the decomposition method uses the factoring by grouping strategy in order to be able to factor trinomials. So trinomials have 1, 2, 3 terms like both of these problems do. When we originally learned factor by grouping, we had 4 terms. So this is going to kind of just take these trinomials with 3 terms and turn them into something with 4 terms. So we can use factor by grouping. Okay, so factor 2x squared minus 9x minus 5. So it's called the decomposition method. One reason is because we're going to break apart this minus 9x right here. So I'm going to go ahead and rewrite the problem. So 2x squared minus 9x minus 5. And in order to break apart that 9x, what I mean by break apart is I mean we're going to rewrite it as like kind of two things that mean the same or have the same value as negative 9x. So like negative 4 and negative 5, or like negative 10 and positive 1. So in order to do that, we have to remember the standard form for a quadratic, which standard form is ax squared plus bx plus c. So if I go through my actual problem, a is 2, that's the coefficient of x squared, like right here. B is negative 9, and then c is negative 5, that's the constant. So a is always the number in front of x squared, b is always the number in front of x, and then c is always the constant term, the one that does not have a variable. So what we have to do is we have to first multiply a times c. So in this case, a times c would be 2 times negative 5. So 2 times negative 5 is negative 10. And then next we just need to copy down b. So b itself is negative 9. And then I need numbers that multiply to that negative 10 and add up to negative 9. So they're always going to multiply to a times c and add up to b. So there's only ever like one pair that works. If you ever feel like you find multiple pairs, there might be a little mistake in there. So one of the best like kind of approaches to when we're first starting off using this method is to go ahead and just write all the numbers we know that multiply to negative 10. We're actually just going to do 10 first, and then we'll talk about the negative after. So for factors of 10, they're 1 times 10 and 2 times 5. Then if we want our like factors to be multiplying to negative 10, then one of our numbers would have to be negative. So it actually gives us like double the amount. So we could do like negative 1 and positive 10, or 1 times negative 10, because a negative times a positive gives us a negative. Or we could do like negative 2 and positive 5, or 2 and negative 5. And then now we need to figure out, okay, which of these 4 pairs of factors adds up to negative 9. So I think it's safe to say like, okay, it's probably going to be the 1 and the 10. And then now I just have to figure out which one is going to give me the sum of negative 9. If I want them to add up to negative 9, I need to use the 1 and the negative 10. Because 1 plus negative 10 is going to give me negative 9. 1 times negative 10 is going to give me negative 10. So that like number that I need right here to multiply to, and the number I need right here to add up to. So then this pair of numbers, the 1 and the negative 10, is how I'm going to break down my negative 9x. So what that means is I'm going to first just copy down the 2x squared, and then instead of negative 9x, I'm going to put a positive 1x and a negative 10x. And then next I'll copy down my negative 5, and then I'm going to go back and just re-explain that last step. Okay, so the pair of numbers that we found that, multiplied to negative 10 and added up to negative 9 were this 1 and negative 10. So then I took my negative 9x and I replaced it with 1x and negative 10x. So between those two steps, I didn't change the value of what I have highlighted in purple. They're both like equivalent to negative 9x because 1 plus negative 10 or 1 minus 10 is negative 9. I just broke it into two separate terms so that now I have 4 terms in total, and now I can use factor by grouping. Okay, so now I have those 4 terms. I can go ahead and start on my factor by grouping, and there's the more like kind of thorough written out steps for factor by grouping is in lesson 19, so make sure you check back there if you need to. So what I'm going to do first is you always want to check for greatest common factor first, which is you would look at the coefficients 2, 1, 10, and 5. Those don't have a common factor other than 1. And then for my variables, there's an x, x. This doesn't have an x though, so I can't factor that out. So there's no GCF that I can factor out here. So then next I go ahead and I break the expression in half, and then I factor the GCF out of each half. So from the first half, 2x squared plus 1x or plus x, I can factor just an x out of both. For the coefficients, like 2 and 1, their GCF is just 1, so I don't need to factor out a number there. But both of those terms have an x, so I can factor an x out. And then remember, you can only pull out the lowest power that they both have in common. So since this second one is just an x to the first power, I can only factor out an x to the first power. Okay, so remember, factoring out GCF is kind of like undistributing something. So you can think of distribution to figure out what you have left inside the parentheses. So you can think, okay, x times what would bring me back to 2x squared? I would have to multiply it by 2 to get the 2 in front. And then x to go from x to x squared. And then x times what would bring me back to 1x? I would just have to multiply it by 1. Because I'm not like changing the value from x to 1x. And then I repeat that same process, but with the second half of the expression. So I do the negative 10x and negative 5. Most of the time, I don't want to say every single time, but most of the times that I've seen, if both the terms are negative, you want to go ahead and factor out a negative with your GCF. So I'm going to start with pulling out a negative. And then between 10 and 5, both of those are divisible by 5. And then for my x's, this one has an x, but this one does not, so I can't factor out an x as a GCF. So I'll factor out negative 5 as my GCF, and then I'm going to like undistribute that from each term. So I think negative 5 times what would bring me back to negative 10x? I would have to multiply negative 5 by 2 to get to 10, and then x to get to x. And then negative 5 times what would go right here? They would bring me back to this negative 5. It's the same number, so I must be multiplying it by 1, so plus 1. And then it's really important to stop after that step and check to see what you have inside the parentheses is exactly the same. So like same exact numbers, same variables, same signs like positive and negative, which it is. So then I'm able to go ahead and pull each of these out. So if we picture this as like one big term, 2x plus 1, one big term, 2x plus 1 over there, I can pull that 2x plus 1 out of each. So 2x plus 1. And then what I have left over after I pull each of those out become its own factor. So an x and a negative 5 become its own factor. So x minus 5. Okay, so this is going to be our final answer, but one thing I want you to keep in mind is that the order that your factors are written don't matter, so that means that the parentheses can be switched. So x minus 5 times 2x plus 1, that would be the same exact answer. So that's important to know, especially for like multiple choice questions, because if you write your answer one way, you have to be able to recognize that the other way is also correct, depending on what answers you have in front of you. And then I just want to show you the check once or twice throughout this lesson. So factoring is kind of like doing the opposite of foiling. So foiling is multiplying, and factoring is kind of like dividing things into factors. So to check it, we would FOIL. So to check, you do 2x plus 1 times x minus 5. And FOIL stands for first, outer, inner, last. So we multiply the first two in each parentheses. 2x times x is 2x squared. And then I would do the outer, 2x times negative 5 is negative 10x. And then the inner, 1 times x is 1x. And then the last, 1 times negative 5 is negative 5. And then I check for like terms. So I have a 2x squared. My like terms are negative 10x and positive 1x. So negative 10 plus 1 is negative 9x. And then bring down my minus 5. And then this should be the same answer, or it should be like the question that we started with. So 2x squared minus 9x minus 5. That was our original problem up here. So that just means that we factored correctly. Okay, so our check worked. Just keep in mind though that this is our final answer up here. Everything below it is just a way of checking our answer. Okay, so example 2. So this would be a good time to, like, if you feel comfortable, you could pause the video at any point and like kind of run through as many steps as you can on your own. I would maybe recommend waiting until after we get to the first step and then pause it and see if you can finish it out on your own. Okay, so example 2. Factor 28x cubed plus 16x squared minus 80x. So I forgot to say it on example 1 because there was no GCF that we can factor out, but you do always want to check for that first. So if we look at the coefficients, 28, 16, and 80, those are all divisible by 8. Wait, hold on, no, 28 is not divisible by 8, excuse me. They're all divisible by 4 at least, so we can factor out a 4. And then this is an x cubed, x squared, and x. So they all have at least an x that I can factor out also. So I'm going to pull a 4x out of both as my GCF. And remember, that means that I can use distribution to figure out what's left inside parentheses. I did that for example 1 a little bit, so I'm going to use the kind of like dividing mindset for this one. So if I take 28x cubed and I divide out the 4x, 28 divided by 4 is 7. And then x cubed divided by x, that would go down to x squared, because you would subtract the exponents, and that's an x to the first power. And then positive 16 divided by 4 would be a positive 4. And then x squared divided by x to the first power would go down to x to the first power, because it's like 2 minus 1 for the exponents. And then negative 80 divided by 4 is negative 20. And then x divided by x cancels out the x completely. So there's no more x at the end. Okay, so I factored out the GCF. So now after this step, we kind of treat this exactly like number 1, but just with what's inside the parentheses. Okay, so remember standard form is, I'm going to write it really small up above. This is ax squared plus bx plus c. So a would be 7 because that's a number in front of x squared. B would be x because that's, or sorry, B would be 4x, that's a number in front of x. And then c would be negative 20 because that's my constant. So what we need to do is we need to multiply a times c. So a times c is 7 times negative 20. So the negative is important. So 7 times negative 20 is negative 140. And then we just need to write down b. So b is 4, positive 4. And then now we need numbers that multiply to negative 40 and add up to 4. So I'm going to go ahead and just stop here. I'm going to write that at the top of the video. That's something that like is so important and so critical to be able to do these problems, is to know that for factoring, we're looking for numbers that multiply to A times C and add up to B. Okay, so multiply to A times C, that's this part, negative 140, and then add up to B, B is 4. Okay, so especially as we're getting comfortable with these types of problems, it's usually best to just go ahead and make a list of all the factors of whatever A times C is. So in this case, negative 140. I'm just going to start with the 140. We'll worry about the negative part after. So 140 should be 1 times 140. 2 times 70. I don't know if it's divisible by 3, but we can use a calculator to check. It's not, because you get a decimal. 140, we can check to see if it's divisible by 4. It is, it's 35. So 4 times 35, 140 is going to be divisible by 5. It's 28, so 5 times 28. Not divisible by 6. It's 7 times 20. And then I think the last one should be 10 times 14. Okay, so here's where for number 1, I took all of my factors for 10 and I just kind of doubled them to write them as the 2 different versions because they're supposed to multiply to the negative 10. It would take not a long time, but it would be kind of annoying to have to rewrite all these factors and make one positive and one negative. So if we know that we have to multiply it to negative 140, we know one of our numbers has to be negative. So if one of our factors has to be negative, we need to look for the pair that has the difference of B. So if I were to subtract them, I would get 4. So that pair is 10 and 14. It's the only pair that if I subtract them, I would get 4. And then because they have to add up to a positive 4, this is a positive 4, that means I need to make my smaller number negative. Because if I made my bigger number negative, made the 14 negative, and I added them up, that would give me a negative 4. And I need it to be a positive 4 once I add them up, so I have to make the 10 negative. So I do negative 10 and positive 14. So I'm going to bring down my 4x's on front. And then now, the part that's inside the parentheses is going to stay exactly the same, but my 4x is what's going to get broken down. So it'll be 7x squared, and then instead of 4x, it'll be negative 10x plus 14. And it doesn't matter what order you write them in at all. You could do negative 10x plus 14x or 14x minus 10x. This time I'm going to switch the order, so I'm going to do plus 14x minus 10x, and then bring down the minus 20. So from the first line to the second line, everything stayed the same. We just swapped out the 4x for the 14x minus 10x based on the numbers that we found over here. And again, from here to here, we're not changing the value because 14x minus 10x is 4x. They're the same overall value. We're just breaking it down into 4 terms so that we can use factor by grouping. Okay, so we've done that. Now I can go ahead and split this in half to use my factor by grouping strategies. So I always have to leave this 4x in front. It can be tempting to have it fall off the problem, but it has to stay in front the entire time. And then I'm going to end up, if I use parentheses here, I'm going to have to have double parentheses. So I'm going to just do a bracket just to keep my work a little bit more organized. And now I split the expression in half and factor the GCF out of each half. So from 7x squared plus 14x, both the coefficients are divisible by 7. That's the GCF between those two is 7. And then between the x's, I have an x squared and x to the first power, so I can pull out a x to the first power. Okay, I'm going to think of this in terms of dividing instead of distribution. Again, it doesn't matter which way makes the most sense for you, just use that way. So I would do 7 divided by 7, which is 1. X squared divided by x to the first power goes down to x to the first power. And then 14 divided by 7 is 2. And x divided by x, that is just like, it cancels the x's out. So I would just be left with the 2. The x's go away completely. And then I'm not going to leave the 1 in front of the x. I'm going to take that off. Okay, and then we'll do the same thing, but with the second half. I'm just going to run through the other one really quick. So this was if you wanted to check your work, you could distribute back in your head. 7x times x is 7x squared. And then 7x times 2 is 14x, so we're good. And then for the second half, negative 10x minus 20, I'm going to factor out a negative because they're both negative. And then both 10 and 20 are divisible by 10. And the 20 does not have an x, so I can't factor out an x. So I can only factor out a 10, negative 10. And then if I divide that negative 10 out of each term, negative 10x divided by negative 10. Negative 10 divided by negative 10 is just 1. And then I don't have any x here to divide the other x by, so that stays the same. And then negative 20 divided by negative 10 is positive 2. And then you can always check your work by distributing back in your head really quick. So negative 10 times x is negative 10x. Negative 10 times 2 is negative 20. And then I'm going to take that 1 off the x again. And then the next thing is to check to make sure that what we ended up with inside of our two parentheses are exactly the same. So x plus 2 and x plus 2, and they are, so we're good there, and we can move on to the next step. The next step is to take those x plus 2's that are inside the parentheses and pull them out of each part of the expression. So inside of the brackets, there's this first part that has the 7x in front, and then there's this second part that has the negative 10 in front. So 4x, I'm just going to bring that part down. And then once I pull the two x plus 2's out, so I'll pull it out here. And then next, I have left over 7x and a minus 10. That's going to go inside of its own parentheses. So 7x minus 10. So my final answer is 4x times x plus 2 times 7x minus 10. And then same thing here. There's different ways to write our final answer. So the order of the parentheses doesn't matter. I don't know why it's not turning into a rectangle, sorry. The order of our parentheses does not matter. So for example, you could also see this written as 4x and then this 7x minus 10 next. And then the x plus 2 next. It's just another way of writing it, but it's the same exact answer and both would work. Okay, so that was 20.1. 20.2 is called the shortcut to the decomposition method when a equals 1. So when it says when a equals 1, that's referring to standard forms. So ax squared plus bx plus c. So you'll notice, if we look at example 1, it says factor x squared minus 7x plus 12. So there's no number in front of the x squared, so that would mean that a, which is supposed to be the coefficient of x squared, is 1. So if there's no number there, remember it's a 1. And then in this case, b is negative 7. C is 12 because that's the constant term. Okay, so this falls under that kind of special case of factoring. So when a equals 1 and we have 1, 2, 3 terms in our problem, there's kind of a shortcut. So, okay, before we get started, I just want to say that you can use the entire process that we used from 20.1 exactly as is. That will still work here. There's just a faster way to do it when you have this specific case. So specifically when a equals 1 or the number in front of x squared equals 1. So when that's the case, we get to kind of skip a lot of the steps, and I'll show you kind of the process, and then we'll check it and make sure it actually works. So typically, when we start our problem, we find A times C. But A is 1, like in these cases all the time. This is when A is specifically 1. And C in this case is 12, so 1 times 12 is 12. So we really don't even have to worry about the A here. We can just say, okay, C is 12 because A is going to be 1. These are always for when A equals 1. And then B is negative 7. So I need numbers that still like multiply to A times C, so or just multiply to C in this case, and then add up to B, which is negative 7. So first we can just list the factors of 12 because they have to multiply to 12. So for factors of 12, there's 1 times 12, 2 times 6, and 3 times 4. So in the first two examples, our like A times C number was a negative. In this case, it's positive 12. So if our product is positive, like positive 12, then we need our numbers to both be the same sign. So what that means is they both have to be positive or they both have to be negative. So since we need our two numbers to add up to negative 7, that means that we have to pick the pair, that adds up to 7, so 3 and 4, but we have to make them both negative because negative 3 times negative 4 would give me a positive 12 because a negative times a negative is a positive. And then negative 3 plus negative 4 would give me negative 7. So that's our pair, negative 3 and negative 4. So when we factor, and I can't stress enough, this is only when the number in front of x squared is 1 does this trick work. So when that's the case, we can kind of skip the whole factor by grouping thing. We're going to set up our two parentheses. And this 1x squared, because it's just a 1x squared, it always has to break down into x and x. And then this pair right here is what fills in the rest of the parentheses. So because 1's a negative 3, I would do minus 3. And then 1's a negative 4, so I would do minus 4. Okay, so this x squared always breaks down into x and x. And then our pair that we find fills in the rest. So negative 3, negative 4. And then we got to skip all the whole like factor by grouping, factoring out GCF and all that. But because we're skipping all that, we definitely want to check to see if this like works or if I just made up a bunch of gibberish. So to check it, we'll FOIL. So for the check, I'm just going to rewrite it down here just so we have plenty of space. So it's x minus 3 times x minus 4 that we're claiming is the answer. And then when we check it, like when we FOIL it back, we should get back to our original problem. Okay, so FOIL stands for like first. I think instead of using the FOIL acronym, I'm going to use one of the other methods we talked about for foiling, and that was to like double distribute. So first I would take the x and then distribute it to both. So I would do like x times x, which is x squared, x times negative 4, which is negative 4x. And then next I'll take the negative 3 and double distribute it, excuse me. So do negative 3 times x, which is negative 3x, and negative 3 times negative 4, which is a positive 12. And then next I need to check for like terms, which I have these two terms that both have x to the first power. So I'll bring down my x squared, negative 3x, or sorry, negative 4x and negative 3x together is negative 7x. And then I would bring down my plus 12, which this is the same exact problem that we started with. So like x squared minus 7x plus 12, x squared minus 7x plus 12. So our trick worked. So our check just kind of confirmed that this was the correct answer. So when the coefficient of x squared is 1, it's a much faster process because you can skip a lot of the steps of the decomposition method. Okay, so example 2, this is the last set from, or the last like example from these notes. So factor x squared plus 2x minus 35. I'm gonna go back really quick to the last problem and just kind of point out like a couple things that you could use to practice with on your own if you wanted to try it on your own before I went through it. So we had a like 1x squared right here that broke down into x and x. And then the other two parts of the parentheses, the -3 and -4, came from the pair that we got when we were like trying to multiply to 12 and add up to -7. Or in other words, like multiply to C and add up to B. So try like pausing it and seeing if you can get it on your own. If not, it's not a huge deal. And we can just play the video after, but it's a good kind of time to check. Okay, so factor x squared plus 2x minus 35. A is 1, so we can use this special kind of like shortcut. Can't stress enough, if there's any other number besides 1, you can't do it this way. You gotta do the long way, like in 20.1. B is the coefficient of x, so that's 2, and then C is the constant, so that's -35. So we usually take like A times C, but in this case A is 1, so it'd just be like 1 times -35. So if you want, you can really just say, okay, C equals -35, because since A is 1 in this case, we don't really need the like A there. It doesn't change anything when we multiply. So that's equal to -35. And then B is 2. So I would need numbers that multiply to -35 and add up to 2. So we should start by making a list of all the numbers that multiply to 35, and then we'll worry about the negative after. So 35 is 1 times 35, and then it's not divisible by 3, but it is divisible by 5. It's 5 times 7, and those should be the only couple like pairs of factors that work for 35. And then since they're multiplying to -35, we know one of our numbers will be negative. If you want, you can just write all the different possible combinations, like 1 or -1 and 35, and then 1 and -35. Or like sometimes that takes a while if you have a lot of factors. So just know that if I need my factors to add up to 2, I have to find the pair that when I subtract them I would get 2, because I have to make one number negative. So the 5 and the 7 would work. And then they need to add up to a +2, so I need to make the smaller number negative. If they added up to -2, I would have to make the 7 negative to get the -2 sum, but they add up to +2, so I do -5. And then now, because A is 1, I can skip all the long like factor by grouping steps and then just set up my two parentheses. The x squared, like 1x squared, is always going to break down into x and x. And then these two numbers are what fill in the rest. So one parentheses will be a -5 and one parentheses will be a +7. And then remember that the order doesn't matter, so you could do like x plus 7 first and then x minus 5 second. So x minus 5 times x plus 7 is our final answer.